Here's your warm-up. And what I'd like you to do is I'd like you to have a conversation and prove that these figures are congruent. Now, they're not triangles, so we're back to before our shortcuts, just thinking about, do I have enough information to prove that they are congruent? If they are congruent, then what we want you to do is write a congruent statement. And when we talk about what is a congruent statement, that's that idea where you say this figure is congruent to this figure. So the idea of what is a congruent statement is we're just stating to everybody, and we want to be careful about what are corresponding vertices and making sure you have things matched up. So would you please, with your group mates, have a conversation about congruence, talk about Euclid's postulates, and then go ahead and pop over to the back of the page to discuss and practice. Go. All right, let's talk about it. So if I want to prove that these shapes are congruent, what I need to do in order for something to be congruent, what I need is I need all angles congruent, because that guarantees that my figures are the same shape. And then I need all sides congruent, because then that guarantees that my figures are the same size. So what I'm going to do is I'm going to go through and look at each of these angles and sides. So do I have a 103-degree angle in my second shape? Yep, there it is. All right. Next to my 103-degree angle, I have a 50-degree angle. Next to my 103-degree angle, do I have a 50-degree angle?
Yeah.
So far, so good. Next to my 50, I have a 71. Looking good. Next to my 71, I have a 136. So as far as I'm concerned, these figures are definitely the same shape because all of their angles are the same and they're all in the same order, right? If I had the angles in a different order, it wouldn't be the same shape, but because now, even though one went ring around the rosy to the left and the other went ring around the rosy to the right, it doesn't matter. They're still going to be the same shape. All right, let's look at my sides. I have 16 feet in between my blue and my green, 16 feet in between my blue and green, so I'm good to go. 32 feet between my green and purple, 32 feet between my green and purple. 40 feet between purple and red, looking good. 18 feet between red and blue. So, yep, all sides are going to be congruent. So when I go to write a congruent statement, I need to make sure that I communicate that I'm dealing with a shape. So this shape is going to be some kind of four-sided figure. It's not a triangle, so we'll just draw a four box. So we're good to go. And then once I lock in the name of the one figure, I'm going to lock in the name of the other. So whatever letter I start off with, that's where I'm starting. So call it out. H. So once I call this figure H, now my next thing is, so this one's definitely going to be M. All right. Now, when I'm sitting at H, I need to decide, are you going to go left around the circle or right?
Right.
Sure. Doesn't matter. So if I go H, then I go to K, then I go to J, then I go to I. You okay with that? So if I start at M, because that's the one that corresponds, which way am I going now? Yeah, I need to go up to P. And once I have my order set for M and P, I know this is O and N. We communicate which vertices match up to with which vertices through the congruent statements. When you're asked to write a congruent statement, lots of times kids get hung up on that fancy word. Like, what is a congruent statement? Like, I don't know. what is a congruent statement. On your quiz, you're going to be asked to write a congruent statement next class. Did you hear that? Next class you have a quiz? So when you're asked what is a congruent statement, then now you know you're communicating, are the figures congruent, yes or no? Do they have all congruent sides so that they're the same size, and angles so they're the same shape? And can you match up corresponding? So this first question is packed with a lot of little bitty details that you need to make sure you don't screw up on. Sound okay? Yes or no?
Yes.
Okay. New concept. Describe how Euclid's congruence postulates, and these congruence postulates are for triangles. So describe how these postulates, and they are side, 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 angle, side, angle, side, angle. How do they cut our work in half? Because this is a lot of work. So when I talk about all of this here, that's a lot of work. That's a lot of stuff going on. So how do I make sure that I can get my stuff done, but with triangles, how do I get away with doing less? Any thoughts? Thoughts? Go ahead, Sabrina.
At least in the homework, if it says we can use them, we won't have to go step by step and prove it. We can just say that we could say it.
Yeah.
And use his,
Yeah.
postulate.
So what's pretty cool is each of these three things means that all I need are 3 facts of congruence instead of 6. So it used to be for a triangle, you had to prove 3 sides and 3 angles, but guess what? The truth is, we don't need 3 sides and 3 angles. Euclid proved to us, if we just have 3 sides, we're good to go. If we just have 2 sides and the included angle, we're good to go. If we just have 2 angles and the included side, we're good to go. So what's great is Euclid went ahead and said, if you have any one of those, you can guarantee congruence and not have to worry about it anymore. All right, moving on. When we write a congruent statement for each triangle, I want to state the postulate that supports your statement. So I'll tell you something right now. All 3 of these sets are congruent. So with your group mates, will you please decide, first of all, which of his postulates is demonstrated? And then I want you to name them using a congruent statement. On your mark, set, go. All right, come back. If we have to write a congruent statement for each triangle, and the interesting thing is, yes, these are all congruent, but the most important thing that I want you to talk about or think about, and this is what kids struggle with, is when we're talking about our included angle and our included sides. So in this triangle, I have these 2 angles are congruent, and I have these 2 angles are congruent, and this included side is what guarantees that it's angle, side, angle. That included side has to be in between the 2 congruent angles. Okay, so here's the fun part. I know fun's relative. When I go to say which triangle is congruent to which triangle, once I name the first triangle, I'm locked into the name of the second. Somebody call out a name of that first triangle. ABC. So original. So as soon as we call this one ABC, we have to start this one with what? D. We have to start it with D. We have to go to E, and we have to end at F. Hey, I'm giving you pointers to get nothing wrong on the quiz, because the quiz next class is so detailed. And you gotta be smart about going about this, being like, all right, lady, I see you. I'm not losing any points for silly stuff like putting my letters in the wrong order. So think of every quiz or assessment as a challenge where you're like, good luck trying to take points off for me, because you won't get it right if you don't list the triangles in the right order. Go ahead.
Wait, so why do you put it in that order?
Because this congruent statement, great question, Owen. This congruent statement communicates through that one sentence which angles are congruent and which sides are congruent. So we want to make sure that when we write a congruent statement, that there's no doubt of what corresponding parts are. Go ahead.
For the quiz, could we use like colored pencils?
Sure. That's why there's colored pencils in the basket. Absolutely. Rock on with the colors. All right. So for the second one, what's my congruence postulate?
Side, side, side.
Absolutely. So side, side, side. And then when I go to write my congruent statement, I know that this triangle is going to be congruent to this triangle. And I can name it. There's 6 different ways to name every single triangle. Pick each vertex and go left around the rosy and then right around the rosy, right? So as soon as you name the first one, you're locked into. Somebody name the first one for me.
HOP.
All right. Triangle HOP. And as soon as somebody calls it HOP, I have to call it SUM. All right, let's talk about this last one. What is my congruence postulate that defends that? Side, angle, side, because that angle is included between those 2 sets of congruent sides. Perfect. All right, well, as soon as I write my congruent statement, I'm locking myself in. Somebody call out the measure or the name of the first triangle. I heard A-N-M. So as soon as we see A-N-M, what are we going to call the next one?
OBJ.
O. And if I go to N, that's got to be B and then J. Very good. All right, so here's the deal. Those are our 3 postulates that Euclid gave us. So I want to be clear in my directions for this next section. Because I say, describe why neither of the triangles below are congruent through these 3 postulates. Now, spoiler alert, the triangles are congruent. They are congruent, but not by side, 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 not by side, angle, side, and not by angle, side, angle. So now my job is to figure out what the heck. So we'll go ahead and we'll look at these 2 triangles first. What do you see? What do you know? What do you need? Talk to me. What do you see? So I've got 2 sets of congruent angles. This one here is congruent to this one here. And I've got this one here is congruent to this one here. What else do you see that you know? I've got this side here is congruent to this side here. Hey, guess what? That side is not included. That side is not included. If I wanted to find the included side, I'd have to be looking at this one, because that's what's included between the 2 angles. Bad luck. I don't have that one. But what could I do? Anybody have an idea? Go ahead.
Since 2 of the angles are congruent, then the third one has to be congruent.
I love it. So Serena says, what about our 3rd angle theorem? Our 3rd angle theorem says, if you have 2 angles in a triangle that are congruent to 2 angles in another triangle, then good news, that 3rd angle is also going to be congruent. Now that I have that 3rd angle congruent, do you see my angle, side, angle postulate?
Yeah.
Because I do have this side now is going to be included in those 2 angles. It's super important that you understand what I mean by an included side. Everybody got that? Yeah. So my 3rd angle theorem and my angle, side, angle postulate makes that totally possible. I love it. All right, let's come over here. I cannot use side, 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 or angle, side, angle. But there is a way to prove that these triangles are congruent. Do me a favor, and I want you to all to channel your inner Pythagoras and talk to your group about how that might be possible. And your mark is set, go. All right, come back. Did you channel your inner Pythagoras and pay attention to the fact that the angle that was given to you was what? A right angle. I have a right triangle from that right angle. So I can go ahead and call the legs of my right triangle A and B. I can call the hypotenuse C. Get into that habit now. Always call it AB and give C the name of the hypotenuse. So then I know that A squared plus B squared equals C squared, and the conversation over at the one group is, okay, well, we don't have any values. All right, that's true. But if I put A squared plus B squared plus equals C squared into that formula, and I solve for B, B is going to be equal to the square root of C squared plus A squared. Let's talk logically. If A and C have the same values, aren't my two B's going to then have the same value? Are you with me on that? So this side of my triangle here is going to have the same measure as that side, because it's going to be the square root of the sum of the same two values squared. Everybody see that? So I know that B is equal to itself, and since that represents both the legs of the triangle, I'm going to say that those are going to be congruent. So when I go to prove this congruence, I can go ahead and I can use my Pythagorean, and then I can go ahead and I can use side, side, side congruence. Pretty cool, yes? Yes? All right. All right, so here's what I want you to do. Take out your homework, please.
That's what's so hard on these proofs. I would do like all my own notes.
Ready? So again, we're talking about this idea of our included angle when we're talking about the homework. So, and of course it happens by whatever point is shared. It's that vertex, it's that angle that's shared between the two sides. Okay? When we start talking about our congruence, I want you to pay really close attention to the math that you did, Sumner, with A and D. Because if you saw A's parallel lines and D's parallel lines, A did not give you the information that D did, because D's parallel lines were told that told you they were congruent. So then you had side, angle, side. With A, you got the alternate interior angles, but that left you with two sides and an angle. That's not one of our postulates. We'll talk about why today. But for the most part, it's no cursing in geometry. Order matters. Angle, side, side, not a congruence justification. So we're going to start seeing overlapping stuff. So this side counts twice. Do you see the two triangles? Here's one, here's the other. So when I have these two triangles, I'm looking at side, angle, side, side, angle, side. So yes, those right angles. And you know that all right angles are congruent. Start paying attention to all the old stuff that's resurfacing. I want you to picture him stirring a big pot of soup. All the carrots and peas hidden at the bottom are suddenly coming up to the top, right? So now I can see, oh, here's alternate interior angles. Coming back to visit. All right angles are congruent. Coming back to visit. What are these called? Vertical angles. So because the vertical angles are congruent, I have now side, angle, side congruence. Here I have side, angle, side, thanks to my alternate interior angles. This shared side gives me side, side, side in letter E. And on F, I have one set of angles and two sets of sides. But that's angle, side, side. I don't have the included angle. I don't have any included side, so nope, not a postulate. Not enough information. All right. So when we're talking about this middle section, we're making sure that you can read a congruent statements. Each of these are congruent statements. Can you get the matching corresponding parts? That was the goal there. All right, I told Donovan by the end of today he was going to be a proof master. By the end of Unit 4, you will be proof masters because we are doing proofs every single day in every single worksheet that we use. Because the unit's all about proving triangles are congruent. So I need you to get good at talking to your diagram. Your baskets on your desks have colored pencils and highlighters. So I want you to get good at drawing on those diagrams. That diagram showed up to you blank. So you're going to take your pencil or colored pencils and you're going to show me, what does it mean to be a midpoint? O is the midpoint. So what? Now what? What does that mean to you? Oh, snap. If it's the midpoint, that means that those two segments are congruent to each other. I wonder if I'm going to get to use that. Oh, it's also the midpoint of NP. What does that mean? Oh, there's two different. And notice I marked it with two different numbers of hash marks. Just because O is the midpoint of those two segments doesn't mean that those two segments are congruent. It just means that it's breaking each individual segment into two congruent parts. We show that by using one or two hash marks. Does that make sense to you? So I get that through the definition of midpoint, good news. Now let's talk about, vertical angles. There it is again, stirring that pot of soup, all those peas and carrots coming up. Now that I have those angles, would you please pay careful attention to the order that I listed those vertices congruent? Because I go ahead and I take the time to communicate corresponding parts. When I talk about angle MON, that's not POQ, that's QOP, because M and Q are going to be corresponding. Those two triangles are congruent through side angle side. Hey, do me a favor, talk to your group. What question on the front of this do you think would make a good quiz question? Turn and talk, go. All right, let's check out the back. I tried to make my explanation of this one longer, and it only needs like a few sentences. As you see, we're given A, B, and C, D are congruent. We're given B, C, and DA are congruent. Our stirring the soup and what's coming up to the top, don't forget our reflexive property of congruence is the one that says that since this segment is a part of both triangles, it's congruent to itself. Now what's important is you need to look here and notice I called it CA and AC because when I talk about where it fits into the triangle, corresponding parts wise, we would have to flip that same segment. That's why I need to take the time to say it's congruent to itself. In the one triangle, it's CA, and in the other triangle, it's AC. That's an important thing. Make sure you understand that. And then I have side congruence. All right, the next one. I'm given, and again, you need to talk to your diagrams. Hey, AB and CB, AD and CB, not only are they congruent, but they're parallel. Pretty cool. And I gotta be honest with you, if you need to turn your shape sideways so that you can see alternating interior angles from parallel lines, extend your lines if you need to. Extend your transversal if you need to, because you need to see these alternating interior angles. They keep resurfacing. Here they are. Because they are congruent and parallel, and this has the reflexive property, I can work my way to side angle side congruence. Do you see it now, Donovan? No answer.
Oh, yeah.
Still.
Yeah.
Okay. Yeah.
What does the second justification say?
Alternate interior angles. Sure. What else you got? Come on. Talk to me. Any questions? So if the proof pantry is something that helps you, these are things that I'm going to go add to my proof pantry. Reflexive property, alternate interior angles, our vertical angles, all the things that are showing up as justifications, I'm going to make sure I know our options. All right, let's talk about this one. What you need to understand about this one is you're given the congruent statement first. You don't have to prove the triangles are congruent. Once you're told that they're congruent, you have all of those corresponding parts, those matching parts, congruent. 3 angles, 3 sets of congruent angles, 3 sets of congruent sides. When I sketch out my triangles, and please take the time to draw these sketches, because once you do, and go ahead, put them in completely lined up order, because it makes it so easy for you to say, oh snap, look, I know that A and D have to be congruent because the triangles are congruent. So guess what that means? The measure of A is equal to the measure of D. Oh wow, I can set them equal to each other, solve for X. Once I solve for X, I'm going to take that value of X, I'm going to plug it in everywhere I can, and I'm going to get all my other angles. That means that B and E are both 10 degrees, and then I'm going to use my triangle sum theorem to get 150 degrees for C and F. What you're doing in this example is called solving a triangle. If you're asked to solve a triangle, it means go get all the angle measures, all of the side lengths. All right. Now when I look at the side lengths, when I mark up my diagram and I put those triangles next to each other with the same orientation, I can see that I have a value for BC and EF. Well, those are equal to each other. So again, I'm going to set them equal to each other, solve for X, and then plug in what I need to know. BC and EF are both going to be 8, and then AC is going to be 19. For number 14, find the value of the variable given that the triangles below are congruent. This one's a little bit tricky because we've got a ton of different variables. So you just need to look at what you have versus what you need. These sides are congruent, so I set them equal to each other, solve for X. X is equal to 5. These sides are congruent, so Z is 14. These sides are congruent. I set them equal to each other, solve for Y. These angles are congruent. Now, it's a little tricky getting this, and did you wonder if there was a typo when you saw V? You're like, did they type the wrong variable? But then I realized, oh snap, 57 plus W plus W plus 7. When I have this matching variable, that's a hint. So then 57 plus 2W plus 7 has got to equal to 180. There's the triangle sum theorem. Stir in that soup. Everything that we've learned in the past keeps on coming back up. We need everything from Unit 1 to do Unit 2, everything from Unit 2 to do Unit 3, everything from Unit 3 to do Unit 4. Yeah. Reviewing for geometry is so easy because we use all the stuff we learn all the time. Once I get W, then I can plug in 58, and then that'll help me solve for my value for V. V is equal to 53. How are we doing? Okay?
You go back to number 12.
V is 53 here because this angle here is 65.
Can
Yeah.
you go back to number 12?
Number 12.
Oh, excuse me.
There you go. All right, with your group mates, please, again, talk about the second side. What do you think on the back of this page would be a good quiz question? Go. All right, so when we're looking at our angle side, it is a shortcut to what we were working with when we had our, using our third angle theorem and angle side angle. All right, so instead of working to find those 3 angles congruent, what we need to do is consider what information is given and how we're going to use it. I know that line segment WY is parallel to line segment XZ, and I know that angle Y is congruent to angle X. Let's talk about what that looks like in my diagram. I have two parallel lines here, and I have these congruent angles here. So my hint here is to use the alternating interior angles theorem. Now again, if you need to turn your paper sideways in order for you to see the fact that with these parallel lines, we get transversal WZ and alternating interior angles, then please go ahead and do that. And then what I want you to do is I want you to be very intentional about how you name them. Once I call this YWZ, then I have to call this XZW. Do you see why?
Can you just say angle W is congruent to angle Z?
Here's why you can't. So Sully's question is, can you say angle W and angle Z? If I say angle W, am I talking about this one or this one? Right?
That's one of them.
Yeah. So because I can't say for sure which angle is angle W, I got to go through. Now, I can call this angle X and angle Y because there's no discrepancy. In fact, when I'm grading your papers, I prefer you call it angle X and angle Y because then I don't have to take points off for you not getting the corresponding vertices backwards. So if you can call it by one, do. All right. Reflexive property of congruence talks about this guy here, and this is where you got to be really careful because I'm going to say that segment WZ is congruent to segment ZW. And I need to make sure that I do switch those sides around because if you notice, this segment here starts at the red. This segment here has to then start at the red. All right, good news, folks. Now that I have angle, angle, side, I can say that triangle WYZ is congruent to triangle ZXW because I have angle, angle, side congruence. And that's what's really cool. Do you see it? Angle, angle, side. I don't have this included side. I don't have this angle to make this the included side, but guess what? Angle, angle, side saves me a step in what I was doing. All right, next up. How come we don't have any angle, angle congruence? Why not? Go ahead.
Because you could always just make all the sides equally bigger.
Yeah. So without having at least one measurement for my sides, what I end up with is something more along the lines of a similar figure. In fact, go ahead and practice drawing what would be a teeny version of this triangle. You could do it with angle Y. You could do it with angle Z. You could do it with angle X. Nobody would in their right mind think that those triangles are congruent. Spoiler alert, they are similar triangles, and similar triangles is our next unit, so we're excited to see that. Hi, Mr. Hammond.
Angle, angle, angle.
There is no angle, angle, angle. But it's a good thing you're here. We're about to start
Angle,
cursing.
side, side.
We are about to start cursing in geometry.
So what?
We're about to start cursing.
There you go, angle, side, side, or side, side, angle.
Oh, yeah.
Oh, it's sense.
When we look at the side-side angle theorem, we're talking about a side and an angle. And looking at this picture, can be a little bit confusing. So I want to go back to your notes for a minute. We have an angle, we have a side, and we have a side. So it looks like those angles are going to be congruent, but I want you to look at the picture below, and I want you to see that I can justify this triangle here. I can justify this triangle here with the same exact measurements that came from the first triangle. Notice angle A is still the same size. The distance from A to B is still the same, and the distance from B to C is still the same. Because I'm missing this angle that makes this side included, because I'm missing this angle, because I'm missing this side, I can justify both of these triangles, and I can do that through this picture. So if you look at this picture, it shows you the two different triangles that can be created from these congruent given facts. And that is because nothing guarantees the length of A to B. Nothing guarantees the angle up at B or the angle down at C. So when we talk about why no angle side side, we can talk about the fact that we cannot guarantee without knowing these facts, both triangles are possible. So go ahead and write it like this, and then cross your cursing out. No cursing in geometry. Every time you want to call it angle side side, you'd be like, nope, that can't be right. Except this. So we just said no cursing in geometry. We just said it can't be it. We just spent time doing that, and then I go ahead and I tell you this. Now again, let's go back to your warm-up. What did we do here? If you'll notice, we had an angle and we had two sides, but what were we able to do in these triangles? We're able to get our third side. We're able to use Pythagoras to get our side. So this tells us that when we're talking about a hypotenuse leg theorem, we only have a hypotenuse if we have what kind of triangle?
Right.
We only have a hypotenuse if we have a right triangle. If the hypotenuse and one of the legs of a right triangle are congruent to the hypotenuse and leg of a second triangle, then we can boldly say that those triangles are going to be congruent. And the reason we can say that is because if we needed to go prove this third side, we could, using Pythagoras. And our side congruence. So here's the big question for you. Can you tell the difference between angle side and hypotenuse leg? With your group, take a look at each of these four sets of triangles and tell me which ones are justifiable through angle side and which ones are not. And your marker set go. All right, come back, let's talk. So can you tell the difference? Can you tell the difference between, someone said, can you tell the difference between angle side and hypotenuse leg? What's the first thing to look for? Come on.
Right angle.
Yeah, so like totally, if you see a right angle, you know you're talking about hypotenuse leg. As soon as I have a hypotenuse, that's because I have a right angle. Remember, your hypotenuse is the side opposite of the right angle. And then, of course, I have this is congruent to itself because of the reflexive property of congruence. Are we good? Yeah, are we all here?
Yes, ma'am.
Alright. So I can go ahead and prove that these two triangles are congruent by my hypotenuse length theorem, no problem. When I come over here, I look opposite of my right angle, and I have my hypotenuse. I have one of my two legs, so I can go ahead and call that congruent, easy peasy. When I look at this one, I have one angle, and I have these two sides. The problem is, neither of these two sides is included in that angle. Well, this one has one of the two pieces. So what's fun to think about is, can you draw, so these are not congruent. I do not have enough info. And if it makes you feel fun to write that and cross it off, that's fine. But are the triangles guaranteed to be congruent? No. Hey, here's something fun. Can you find the other triangle that they could be? With that blue angle and that green edge and that purple edge?
Similar.
Can you find the other possible triangle by swinging one of the legs? Which one are you gonna swing, purple or green?
Green.
Just one purple.
Green can't be swung because it's married to that blue angle, right?
Yes.
So which one am I gonna swing?
Purple.
Yeah. So let's go ahead and take purple, and if I drew that same side, and I can call this C1, with that given information, A and X having the same measure, the green side and the purple side, you don't know which triangle we're talking about. I assume this is a Z. You don't know if we're talking about ABC prime or XYZ. Therefore, it's not enough information. All right, so when we come over here, I've got my angles congruent, lovely. I've got one side congruent, awesome. But then when I go to look at my next side for congruence, it's not giving me what I want. Now, I gotta tell you something, it's not possible to draw another triangle here because angle E and C are obtuse. So I'm not going to be able to swing this one. But because angle side does not work all the time, it can never be used as a justification. Go ahead.
Could you prove that A, B, C, and E, D, F are congruent if we knew that, like, we know that C and E are congruent?
Uh-huh.
But if we knew that one of them was obtuse, could we then use SAS?
Yeah.
As
If I
SAS?
had one more piece of information, then yes, I could. Another angle, another side, and I'd be good to go.